Good morning and thank you for joining us. We still have people rolling in, so I am going to go over a bit of housekeeping this morning. So first of all, you have a control panel in front of you that has gray bars going across it. The first item up is the audio tab. If you're having any audio issues, things are breaking up, bandwidth issues, whatever it may be, you can drop that tab down and then there is a phone call in method. You can push that button and then a telephone number and a access code will pop up. As long as you're on a good cellular connection or a landline, this may resolve some of your audio issues. Next is, just one second. Next is the questions tab. The way that we typically run our webinars is through the questions tab. So I see you can actually undock the questions tab. There's a square with a check mark in it. And you can push that button and then it will open up a separate pane that you can open, pull the edges and the sides and make it larger. So I see Christopher's already chimed in this morning, but if someone could just chime in on the questions tab, let us know. You can see the presentation. You should see my beautiful face this morning. You should see heat pump deep dive and a couple of pumps on the page. If someone could just chime in, tell us good morning. Let's make sure everyone has coffee and has had their breakfast and is ready to go to do some learning. Good morning, Thomas. Appreciate that. Thank you very much. Rod, appreciate that. Darren, thank you so much. Appreciate all the comments. Okay, moving forward. In the handouts tab, there is a copy of today's presentation in PDF format. You can download this at your leisure and then utilize it to make notes, follow along, and then also future reference. So please download today's presentation, a copy of today's presentation in the handouts tab. And then just so you know, tomorrow I will put up both presentations. So this is a 2-day class. It's spread over a couple of days for a reason, because it is a lot of content. What this does when we spread it out is a couple of things. Is it allows for a better learning experience, because it is a lot of content, and then a lot of people can't show up for a 4, 6, or 8 hour webinar. So that's the reason why it's split up. So what will happen on day 2 is I will actually put up both presentations. You'll have 2 copies in PDF format. So that will happen on the second day of the class. And so next, let's go into safety. So PG&E, we take our safety very serious. So please speak up for safety. Several of you may work out in the field on different job sites. If you see a safety issue, you have the power to stop work, correct that safety issue, identify it, tell somebody, whatever it takes. And the reason for this is because it's your responsibility to be safe for everyone, not just you, but your coworkers. So, if you see a safety issue, identify it, and then of course, stop work, correct the safety issue, and then get back to work. And so next is please follow good ergonomics. During the course of this presentation, I suffer from back pain, and so what I typically do is I throw a pillow behind my back. It causes me to set up straight, corrects my posture, maybe something that you want to do as a recommendation. Next is please remember to stretch and hydrate during the course of this presentation. In the event of an emergency, we are going to call 911. If you're calling in from California, this is earthquake country. I have been on webinars when we've had earthquake events. So in that event, we're going to drop, cover, and hold, meaning you're going to drop under a heavy piece of furniture or a doorway. You're going to cover your head with your arms and hands as much as possible, and then you're going to hold in place until the shaking stops. Unfortunately, in today's times, we do have to talk about active shooter. In that event, we're going to get out, hide out, or more importantly, we're going to take out that individual. Please remember your evacuation plan and path of egress out of your home or place of business. Utilizing emergency exits if required, and then hopefully you have a place to meet in the event of emergency outside the home, such as a fire. If that happens, then hopefully you have a place outside the home or the place of business that it is safe as a gathering point in the event of an emergency. The most important thing on this slide is highlighted in yellow at the bottom, and it's call 811 before you dig. And so I've become an ambassador for 811, call before you dig. What this is a free service offered, across the board from all the utilities in California. When you call this phone number, you provide, name, address, pertinent information about yourself and where you're digging in the ground. what will happen is I've utilized this service personally. And so I've called in the morning, I've had utilities showing up, by midday that same day. So please utilize this service. You'll have utilities, Comcast, telephone services, things of that nature showing up, and they will mark out the lines to make sure that it's safe for you to dig in the ground. So please call 811 before you dig. We're still in this pandemic. I do want to share with you, I got COVID back in July again. I think it was probably my second or third time. And the reason I think I got COVID was because I went back to shaking hands. So what I've done instead is I've went back to the fist bump. I've been very cautious with who and how I handle things. I went back to utilizing hand sanitizer and things of that nature. I've had several colleagues and several of their kids that have gotten COVID over the course of the last 3 months. So just take care of yourself. Remember to wash your hands at least for 20 seconds. Utilize hand sanitizer after you handle items from others or cough or sneeze. Prime example of this is when you refuel your vehicle, you jump out of your car, you grab that fuel pump, and lo and behold, you jump back in your car, you got COVID. So that's a prime example of when I use hand sanitizer. Just a suggestion, use it as you will. So go bag's very important, especially with the wildfires in California. This year we actually got off pretty easy, I think. So I'm very thankful for that. Please make sure that you have one, you create one, keep one, you put it in, throw it in a closet, you always have it. Some items you would want in a go bag or medications, pet food if you have any furry ones running around like I do, water, cash, credit cards, changes of clothing. These are just items that you could utilize in the event of an emergency as a way to take care of yourself and your family. And here's some facts. There's a reason why the military has bug out bags, and this is a prime example. So create one, keep one, throw it in a closet, you always have it. And this is being recorded. I do have authorization from DNR, which puts on these classes for us, to put these up on demand. But I do want to make a statement. On demand is great, but currently you have a subject matter expert. You have a couple of subject matter experts sitting in front of you today in the form of some instructors. And so, I want to share with you that on-demand content is great for on the go and when you're trying to get information, pretty quickly. But ask questions, be involved in this class. Please make sure that you're, involved in the class, asking questions. Like I said, you have two subject matter experts in front of you today in the form of instructors, Lester and Christy. And so please utilize the questions tab, ask questions, be involved in the class. They also have some polls. Please participate in those. It makes the class that much more interactive. And this is our disclaimer slide. During the course of this presentation, D+R and the instructors may share different products or manufacturers. PGE is not endorsing any one product or manufacturer, so please remember that during the course of this presentation. And this is my QR code to my classes. You can use your camera phone. As long as it's a newer smartphone, it has the technology to be able to identify this QR code. And so what this does is you could copy this, you'll see it pop up, and then you can go to my website. You could bookmark it. I have 60 plus classes on anything and everything that you would want to know about HVAC. Some of my new classes I have coming up is 3D residential modeling for load calculations. And so this is a way that gaming is being introduced into load calculations, which can be incredibly boring. From my perspective, that's only my personal experience. So this may be a class that you want to take. I have some classes coming up. I have 2 classes actually on refrigeration, new generation refrigerants. What that means for the country and the direction that we're moving as far as new technology when it comes into play with refrigerants. So those may be classes that you want to take a look at, but you can bookmark this and then utilize it for future reference. You can actually download and take classes from your phone. We are very mobile friendly, so please remember that in the future. I think that's enough out of me. I'm going to turn it over to Lester and Christy. Please enjoy the class. Thank you for attending. Christy or Clarence? Lester?
There we go.
Yeah, Jordan, I think you're up.
Hi all, I'm Jordan McCarthy with DNR International. My colleagues Lester and Christy are presenting Heat Pump Deep Dive today. It's going to be about a 2-hour course, and we've got a bathroom break planned in the middle for coffee or water or anything you need to do. If you have a smart device handy, please have it ready for our Slido pools. The class, as Brian mentioned, is more beneficial to you as an attendee when you're interactive with our subject matter experts. Without any more ado, here's Lester and Christy with Heat Pump Deep Dive.
Hey, good morning. Just want to welcome everyone to Heat Pump Deep Dive. My name is Lester Terrence, and I will be here with my co-host Christy Podelnik, and we will be going through Heat Pump Deep Dive with you. But before we get started, we're just going to give you a quick introduction from the instructors, myself and Christy. So I believe I am up first. Once again, my name is Lester Terrence. I will be your instructor today along with Christy. My background is in HVAC. I have been in the industry for roughly 20 years, started my career with the United States Air Force, where I served for roughly 12 years. Had the opportunity to travel to different U.S. Air Force installations globally and perform heating and air conditioning installation maintenance and also diagnosis. I continued my career with the Department of State upon my separation from the Air Force for an additional 7 years, where I got the opportunity to travel to embassies and consulates globally, performing the same diagnosis, maintenance on different HVAC applications, and also providing support to different field technician teams that were performing those same um, installation maintenance and diagnosis, but as a field supervisor. And then now I am currently an instructor and instructional designer to DNR International, where we create these brilliant courses that provide information on different parts of the HVAC field. I am very happy to be here today with you and look forward to going through this course. Christy.
Yeah, hey, I'm Christy. I am the lead instructional designer for all things commercial heat pump water heaters. So I'm here today. I'll join in with Lester to talk a little bit more about the domestic hot water side of heat pump applications. I'm the lead designer for the DNR instructional design team, and I'm also a nationally board certified instructor with over 15 years of experience in education. So you'll see my face a little bit more at the start of today's session and then a lot more on Thursday, which I do hope you join us for. The way we have this course divided out, we're going to focus more on comfort heating and cooling today and then look more at domestic hot water applications on Thursday. And then we have in the background, we have Jordan McCarthy, who's our moderator. So if you have questions that pop up, please throw them into the questions tab. Jordan's going to keep an eye on things and make sure that those questions are heard from us or are shared with us so that we can address them like in the moment, meet your needs where you're at. I have my co-host here too. My cat has attended every webinar I've ever taught. He is also on the sidelines, just making sure I'm doing my job. So you've got like a whole host of experts in front of you today. Cool. So let's talk a little bit about what we're doing. I had a little lag on my computer. I was waiting for you to advance the slide, Lester, and I was like, it's not going. We got there. So like I said, we're going to chunk this into 2 parts, and Brian introduced that too. We're here together for 2 hours today. We'll be back together for 2 hours on Thursday. And today our focus is really on heat pumps and comfort heating and cooling applications. So specifically, we're going to start by looking at the what, the how, and the why of heat pumps. That's where you'll hear me speak more. And then I'm going to hand things off to Lester because he has so much field experience with this, like really phenomenal. You're super lucky. He has, like you said, years of experience. And he's going to talk a little bit more about the evolution of heat pump technology along with heat pump applications specifically for comfort heating and cooling. And then Thursday, we'll get back together. We'll look at heat pumps in domestic hot water applications. We'll look at some essential considerations for those because it's a little bit newer. It's a newer take on a really well-established technology. And then we'll spend some time looking at successful case studies.
I just want to throw in there, Christy. I want to let everyone know this is the way the deck is built is really, really brilliant. So, like Christy said, today you have the air conditioning and heating portion of heat pump technology. And then on Thursday, you're going to have the domestic hot water portion to the heat pump technology. So pay very close attention as we go through this because you're getting the best of both worlds out of a technology that is emerging.
And make sure, so we have the PDF of the slides shared as a handout today. So make sure you grab a copy of that. That's yours to keep to follow along with if you'd like. We'll have another copy available on Thursday too. Let's move on to our first poll, Lester.
Yeah. Okay. So we've got the intro survey coming up. But before we get into that, just want to give you a brief introduction to Slido for those of you that are not familiar with the Slido application. Just want to let you know that Slido is a free application that we're going to use today to perform our polling sessions, any question and answer portions of the instruction today. So in order to access Slido, you're going to head over to slido.com by opening up another tab in your web browser and entering the event code heat pump. Or if you have the mobile device readily in front of you, you can scan the QR code that you will see on every polling session that comes up today. And you can scan that QR code and it will take you directly to the event. And you can take your time and participate there at that time. So in order for us to just make sure that everyone is is able to access the Slido application, we are going to jump into an introduction survey where you will either scan that QR code at the top left-hand corner of the screen or enter at slido.com with the keyword heat pump. And what we're going to do here is just take some time. How much time would you say we want to give this activity here, Christy?
I mean, let's just hang out. I see there's already a couple of people responding. I super appreciate that. We like to use the interactive polls to interact with you, hear what you have to say. This is just a get to know you, so we start to learn some of the faces that are in the crowd with us. We take what you say. You see my coworker, my other manager right there. We take what you say really seriously. So when you have questions, we'll try to make sure that we're addressing them somewhere in the webinar. At the end, we'll have a quick survey for you to fill out on your way out. We take all your comments and suggestions like really, really seriously. So I highly suggest that you engage, tune in, grab your device, and while people are working on this, oh my God, like 10 people I really appreciate that, folks.
Yeah, that's a lot in there.
Yeah. Lester, how are you doing today? We'll just banter a little bit, fill that silence.
Yeah, I'm good. I'm good. You know, this morning I don't know why I just had a feel to watch Dragon Ball Z, like the first season. So I started it over.
Oh my gosh, that was the first anime I ever watched in my life, and
Me too.
right?
Mm-hmm.
Not to date ourselves, but it's an awesome anime.
Oh yeah. I love it. I made it to the end. I kind of skipped a couple episodes because Vegeta is like one of my favorite characters, so I just wanted to see him go crazy.
Lester and Christy, we do have a few questions, related to content, maybe as we're, requests for information for the presentation. This first question is, what do you think of multi-stack heat pumps and their lifespan and other types of heat pumps?
Oh wow, that is an interesting. Yeah, that's an interesting question. I actually, I'd like to know who asked that question because I am a certified multi-stack technician, overseas technician. Multi-stack I was introduced to through the State Department, and they are the entity that I know of that primarily utilizes these systems. They're very complex systems, and now that they have gone into the heat pump technology on a lot of their systems, I have not had the opportunity to work with them. Before I left, I worked with Multistack and a lot of their modular chiller systems without that heat pump technology. But I will say this, if it's coming from Multistack, you have a really good product. You have a top priority product And multi-stack is a system that, if the U.S. Department of State is utilizing it for their very, very extreme missions, and I believe that if whatever technology they have coming out with heat pumps utilizing their systems, it's going to be extremely efficient at what it does. Um, but as I may have driven a little far off from the question in itself. What was that question again?
So what do you think of multi-stack heat pumps and their lifespan versus other types of heat pumps?
Yeah, so multi-stack, if you're talking about a commercial application, is the only application I've worked on multi-stack. I don't even believe they produce anything residential. So from my experience, like I said, working with multi-stack, I had the opportunity to go to their factory out in Wisconsin twice and visit their schoolhouse. So I can tell you that their product is a good line. As far as their heat pump technology, I have not had the opportunity to dive in that space as yet. But like I said, I've had the opportunity with their modular chillers, and those are excellent systems, very efficient.
And Lester, there's a follow-up comment here, specifically for healthcare applications related to these multi-stack heat pumps.
Specifically for healthcare applications, it boils down to, it always boils down to application. And when you're talking healthcare, there's a lot involved there. What type of a facility is it going to be? Is it emergency only, or a lot of surgeries happen in there, or any laboratory testing? A lot of these different things come into play when you're trying to pick a system for a specific facility. So you have to really have what your application is down before you can really make determinations on what type of units or systems would work for that type of application.
Let's take a look at this intro survey. I see there are some really specific questions in here, and hopefully we can address them a little bit later on. But let's go ahead and kick things off about how is everyone doing today. Great. We've got a lot of positive learners ahead of I can already tell, because questions are popping up, we've got people who are here for it. And I'm really excited to explore even more about this. A lot of good who are easing into the day. Make sure that you top off your coffee. We'll take a break halfway through. And only a small percentage are like, oh, what is this? Where am I? This is great. Help us get to know you better. What do you do, and how long have you been doing it? So let's do a little scrolling. We've got The Way of the House Husband. Oh, I did watch that. That's awesome on anime, on Netflix. But we have a building inspector, commissioning engineer with almost a decade of experience, an architect who's been doing this for 40 years, mechanical engineer, 40 years. Keep scrolling.
They're still coming in.
Yeah, we got some people who are bringing it today. I manage a team of 16 project managers, executing sustainability for, I'm going to say, school districts, energy specialists, HVAC. Been doing energy audits for over 10 years. HVAC and plumbing design. Yeah, welcome everyone. I love this question in particular because we get a sense of who's in the crowd and how this information is being used, but also I think it's worth saying that Lester and I have done a lot of work around this content, around these webinars, presentations, staying up to date on the technology, but there's no competition for the breadth of knowledge that is present here today. So if there are questions that are being asked and you feel like you have something to contribute to it, throw something into the Q&A for us, because we would love to hear it. Yeah.
Absolutely.
I know, especially this is a meeting of the minds, I feel like. And then rate your current understanding of heat pumps, a lot of dabblers, which is really exciting. And then some masters who can teach the class. I'm excited to hear what they have to say.
All right.
Yeah. So we're not going to address all of these questions right here and now, but we do like to take a look, scrolling through it and just make sure we're tackling them. I'm sure I'll think of some. We've talked about the multi-stack, heat pump tech for replacing hot water tech, like boilers. Yeah, that is basically all Thursday. So come and check that out. I'm looking forward to learning about newer heat pump technologies, alternatives for electric water heating, heat pumps, what are about ground source heat pumps in California, air to water heat pumps for production of hot water. Yeah, that's all Thursday. And if you look at the PDF that we shared with you, it's the second half. So you have the slides for both Tuesday and Thursday, and the second half is in there. Some people are just here to see if they can learn. Central systems, that's Thursday. Electrification of campuses, heat pumps. Oh, I love that because I'm pretty sure, Lester, when you talk about VRF systems today, like that is check that box, right?
I believe so. Absolutely.
Yeah. Cool. All
And
right.
Christy, Lester, there's also a question about gas absorption heat pumps.
You know, I think we're going to just put a pin in that one so we can move on, and maybe I don't know that we're going to tackle that one directly, but I do want to like start to move into the content, if that's okay.
Yeah, I think
those
we
are
could,
really good questions. I think maybe we should look at tackling them specifically at the end, because we could stay on a little bit longer to talk more about that, very specific. Yeah, so that wasn't to say like don't keep posting them, keep on posting them. We're just going to start to move into the content right now. So let's talk about the what, the how, and the why of heat pumps. And this is for those people who are like, why bother? Why are we even talking about this? Well, there's a couple of pretty big reasons. Let's go ahead and advance on, Lester. So heat pumps, we generally consider them, like I do in my mind's eye, a solution to a number of the problems that we're facing, a number of the challenges that are before us, and really, like, it's pretty urgent, these challenges that we're looking at. Specifically, we're looking at decarbonization goals, we're looking at energy efficiency needs, and on top of all that, we have greater things to think about, like grid stability. So up on the screen in front of you, there's a couple of graphics to represent these ideas. And on the left side, awesome. On the left side is a graph from the U.S. Energy Information Association showing our federal and state, for this one it's California, decarbonization goals for 2050. And they're pretty ambitious. This is nothing new. This has been around for almost like half a decade now, so about 5 years. And those goals really haven't changed. We're still trying to achieve net zero carbon by 2050. So part of that, like part of achieving those goals federally, for the state, locally, is going to be thinking about using building technology that doesn't require fossil fuel resources. And that means we're going to have to start to electrify. And heat pumps are part of that solution because they don't use gas. They don't use carbon resources. They use electricity. Now, there's a greater conversation. I feel a little bit nervous, like I'm unpacking a can of worms here. Where we get that energy is also an important part of that conversation. And we could spend a lot of time talking about that here. So we know we have to generate clean energy to use it for electrification to really be valuable to helping those goals. And that's part of that too. But one of the steps, at least boots on the ground in the field to meet that goal, is a heat pump. We also know that heat pumps are really energy efficient technology, and like heat pumps for comfort heating and cooling are pretty well established as efficient technology. The one that we're now all facing and kind of wondering about is heat pumps for domestic hot water applications. So that graph in the middle that Lester was just circling with the laser pointer, that was actually a study done back in 2018. It was a house, a multifamily market rate apartment housing, multifamily building in Seattle, and it had a traditional boiler system. And it was replaced. It was a retrofit replacement for a commercial heat pump water heating system. And the results kind of speak for themselves. The energy savings were about 17%. So the commercial heat pump water heating system cut down energy usage by about 3 times. And that's significant. And that's going to be really, really important as more people begin to electrify, and that energy has to last longer. It has to cover more houses. So being energy efficient is a really, really important part of our step moving forward for electrification, for meeting decarbonization goals, and heat pumps do that. They are 3 times more efficient than most other technologies, which is a really exciting prospect if we can get over the hurdle of what is this and how do we actually use it. And then finally, But that like energy efficiency piece plays into grid stability, which we know as more people become electrified, not people themselves, the buildings become electrified, it's going to be a greater draw on the grid. And I mean, where we are currently, we're struggling with that. We have brownouts, we have blackouts, stuff like that happens, wildfires. I'm glad Brian mentioned this because California did have an easier year with wildfires, which was great. Like, you could use a break, honestly. But there's other things to think about, like peak time of use hours, when everybody is coming home from work and drawing that power to cool down their houses, to cool themselves down. Heat pumps, especially in domestic hot water applications, can use the hot water storage as a thermal battery, so they can power down during those times of peak usage and ride it out. And that's going to be a really important part of maintaining grid stability, you know, having demand response capabilities, load shift capabilities, being able to cycle when it's not the peak time of use rates or peak time of use. And heat pumps can accomplish all of that, which is why we're here speaking about them today. So let's move on to the next one. So starting, like, let's make sure we're all speaking the same language. A heat pump is a device that transfers heat from one medium to another. Like, that's it in its basis, in its most basic form. It is a piece of technology that takes heat from something and moves it into something else. Next one, Lester. I'd like to think about heat pumps in buckets, though, because it's a device that moves heat from something to something else. That can have a lot of different applications. It can look a lot of different ways. So here's kind of how the lay of the land. This is how we bucketed our content, how we're going to be talking about it today. So we think of it as two buckets. There's heat pumps that can be used in comfort heating and cooling applications, and then there's heat pumps that can be used in domestic hot water applications. And that's what this graphic in front of you is representing. So on the left side of the screen, we have heat pumps for comfort heating and cooling. This is pretty well established technology. It's been around, like Lester's going to talk about it, and not to be a spoiler, but it's been around since the 1920s. Like, it's tried and true. We know it works. We've used it for comfort heating and cooling. It can look a lot of different ways. You can have a mini split system. You can have a VRF system. You can have a monoblock. And these are just different applications to meet the needs of different challenges. And they all accomplish the same thing, comfort heating and cooling. And then our other bucket is heat pumps that can be used in domestic hot water applications. So these are things like integrated heat pumps. Those are your like-for-like hot water tank replacements. There are split systems. There are plug-and-play systems. There's a lot of different solutions for different applications. And then within these, like within comfort heating, cooling, and domestic hot water, we can look at residential solutions, we can look at multifamily solutions, we can look at commercial solutions. So when people say like, oh, we're going to talk about heat pumps, I find it's really valuable to say, to lay that out. Like, here's the lay of the land. Like, let's identify how we're talking about heat pumps. We're talking about heat pumps in comfort heating and cooling. We're talking about heat pumps for residential solutions. And today, that left side, that's what Lester's going to be talking about, is all the comfort heating and cooling applications in both residential, multifamily, and commercial applications. All right, one more, Lester. So speaking of which, like, this is just to represent it. So you know we have comfort heating and cooling, domestic hot water. We also have residential applications, commercial applications, and then somewhere kind of in this fuzzy ground in between, we have multifamily applications. So looking at the screen in front of us, on the left side, we have two examples of heat pumps being used in a residential application. The one on the furthest left is a comfort heating and cooling heat pump, so that's used for air conditioning and heating. And then the picture on the right is an integrated unit used for domestic hot water. So residential, but they can be used for comfort heating and cooling, or they can be used to produce hot water. And then on the right side of the screen, we have heat pumps, again, that in a commercial setting that can be used for, so on the, that one right there, we have heat pumps that can be used for comfort heating and cooling. Those are the Mitsubishi City Multi heat pumps. It's part of a much larger VRF system for a commercial Actually, it's a community building, which has a lot of different needs. Really interesting. We're going to look at how that worked out. And then on the farthest right side, we have heat pumps being used for a multifamily building, which falls under the commercial umbrella, and we'll talk more about that on Thursday. But we have heat pumps for a domestic hot water application in a multifamily setting. So there's, like, bottom line, heat pumps are used in a lot of different ways, and we find it really valuable to sit down and talk about it like this first and say, this is the lens that we're looking at this through, but look at the possibility. This technology is a solution, and it can be adapted for a ton of different challenges. Okay, so grab your smart device or open up another browser, because we'd like to hear from you. That was a short, fast, and sweet version of like the what, the how, and the why of heat pumps. But we'd like to know from your perspectives, especially because we have a lot of people with experience in the field here, what's the greatest value proposition for heat pump implementation? You can speak to whatever you want to. You can speak to comfort heating and cooling applications. You can speak to domestic hot water applications. You can speak to your own experiences entirely, but we'd like to know your opinion. And then how about while you're typing in that, let's check in. Jordan, how are our questions looking?
So we've got an interesting one here. Can you delve into why heat pumps are now being used or engineered in colder climates when historically they wouldn't suffice?
Well, I can speak to it from the domestic hot water perspective, because we just had 2 companies release heat pumps that are like intended for colder climates, literally in the span of 30 days. Nile just announced their new ultra efficient cold weather heat pump water heater, and then Sanco 2 also announced a cold weather heat pump water heater. So these are heat pumps intended for domestic hot water applications. And from what I've learned, what I've gleaned from it by like talking to the reps, is that the intent here is that we know heat pumps are the direction we need to move with technology. There are a ton of incentives now with the Inflation Reduction Act, like a lot of incentives that focus specifically on heat pumps. States are starting to think about it strategically. It's starting to go into code, building code, that you have to use heat pumps for your domestic hot water and your comfort heating and cooling applications. So, you know, in the past, heat pumps have been limited by the climate. They're not very efficient in really, really cold temperatures. That's not the case anymore. There's new refrigerants, inverter-driven technology, and some new design features that are actually making them really, really good candidates for places that do have really cold design parameters. So I think part of that is to meet those legislative goals. We know the technology has to be able to, it has to work in Spokane, Washington, it has to work in Phoenix, Arizona. And there can be like tweaks on that technology along the way, but traditionally they've only worked in kind of warmer climates, and now they're starting to expand into the colder climate areas with some newer technology. So we're getting some answers to roll in. These are looking amazing. Reducing installation costs and parts. Yeah, there's no gas line. You don't have to worry about that anymore, which is a great sell. BT dubs for parents, for adults and children who have respiratory issues on top of that. Like, guess what? There's no gas in your house. So that's awesome. It saves money and it saves the space. The ability to reach net zero carbon goals. I love that stewardship, like, line of sight. Efficiency, easy to maintain. Yeah, check that, check. Replacing gas-fired building HVAC system boilers and heat pumps to produce HVAC heating hot water. There's some ways to like move the systems together so they can work with each other. I was just at a dairy, actually, that is looking at some really interesting ways to implement heat pumps. With like recycling the heat from milk to go back into the sterilization process. Right, that's crazy. They're taking heat from living, breathing things and putting it into sterilization water. Economical in the right location, and maximizing cooling. direct replacement for aging gas rooftop units, yeah, that's coming up a lot as we're looking at what we can replace with. Lester, do any of these jump out to you?
Yeah, absolutely. I know when you were speaking of the heat pump systems years ago not being able to keep up with especially on the really on the AC side, heating and cooling side, we dealt with that quite often. So people or clients who did get heat pump systems would often have to add an auxiliary electric or gas pack accessory in order to have that emergency heat when needed. So they have come a long way just due to refrigerants and its advancements in the last few years. They're stay able to stay in operation below zero. So that is fascinating to me.
I just went to a webinar about the new Sanco 2 like cold climate heat pump that was announced, and they're like the change in it was actually at the bottom of the drain pan. They put in a heating coil, so now when condensation happens and it drips down to the bottom of the pan, there's a heating coil that it's just a little bit of energy that goes through it that's sacrificed, but it keeps that water from refreezing and then stalling up. Stalling up the coils isn't the right way to say it, but I think it keeps the heat pump from needing to go into the defrost cycle, and so it's applicable in places that have temperatures as low as they're saying like negative 25 degrees. I know that's not the temperature year round for most places, but to me I was like, cool. So they are at least 100% efficient up to 5 degrees, and then after that the efficiency starts to drop because negative 25 degrees Fahrenheit. But
you're starting to get the heat, the content of heat in that temperature of air is starting to get smaller and smaller.
So thank you everyone for participating. Love to see this. Even if I didn't read your answers here, I want you to know that after the webinars, we look at this to see what you're saying. And so we find your comments really, really valuable, especially for informing how we present and what we present. So thank you for participating. And I think we can move on to pausing for any more questions.
Yeah, there is a follow-up question here, Christy. How do you incorporate a thermal gradient header with heat pumps and other systems?
I have no idea. Lester, can I hand this one to you?
Can you repeat the question one more time? I didn't hear the entire thing.
How do you incorporate a thermal gradient header with heat pumps and other systems?
I'm going to have to do a little bit of research on that one. I'm not familiar. But if you take that question down for us, we will definitely look for an answer and try. If not today, we can get you something back by Thursday.
We're experts in our field, but we don't have all the answers. So if there's someone out there who does, we've got a ton of experts here today. Throw that into the chat because we'd love to hear it too. Otherwise, we're going to go do some research and come back to you on Thursday with an answer. But if there's someone here who knows it, would love to know. We'd love to hear from you.
Absolutely.
Okay, I'm going to pop out and just hand it over to you, Lester. You ready?
Sounds good, Christy. Yeah.
Okay.
All right. So like Christy said, we're going to go ahead and get into the evolution of heat pump technology, just so you have an idea of where that technology originated from and how far it has come over the last few years. So we know that heat pump technology isn't anything new. It's actually been around for quite some time. And we were using or utilizing heat pump technology on some of our very first appliances, such as the first refrigerator. If we look up to the top left-hand image here, it shows a classic refrigerator from the early 1900s that has a heat pump that is seated on top of the appliance. Now, this compressor or type of setup on this refrigeration system was known as the GE monitor top, which was due to the compressor being mounted on top of the refrigerator. Now, for those of you that are into fun facts, I found this pretty cool when I was doing the research on this. The refrigerator that we know as the GE monitor top came around in 1927, but it quickly gained the name monitor top because of the top mounted refrigerant compressor, which resembled the gun turret on a Civil War ironclad ship named the USS Monitor, therefore the monitor top. So that was a nice little piece of history there that includes the heat pump system. Now, as technology got better over the years, heat pumps started to be incorporated into everyday equipment, such as air conditioning systems, as we see here in the middle, the top middle, and to the top right within automobiles. So these systems featured the same vapor compression cycle heat pumps have within these systems, even some of the systems that we are using today. So as technology got better, we started incorporating this heat pump technology, which started using safer refrigerants, and it gave our appliances the ability to use less energy. Therefore, you'll find them in your day-to-day appliances, such as dryers, your residential heating and cooling systems, as we have spoken of earlier, and even in your water heaters for your pools, whether that be a commercial or even a residential system. Now, we're going to briefly touch on how does our heat pumps work. We understand that the heat pump is operating by the use of the vapor compression cycle. Now, I'm not going to spend too much time here because we are running a little behind. But what I'm going to do is I'm going to go through what the vapor compression cycle looks like in our air-to-air source heat pumps. And then we'll talk a little bit about our water source that you can see on the right here. But in our air-to-air heat pumps, what's happening is you're going to have a low pressure, low temperature vapor that's going to be transferred from your outdoor coil, which is typically your evaporator in a heat pump system. And what's going to happen is that refrigerant is going to go through your reversing valve if you have a or a metering device. If you I'll tell you what we'll do. We'll talk about the heat pump system first, because I always get these two a little bit confused when we talk about AC, just due to the reversing valve. But we'll keep it strictly heat pump right now, and then I'll talk about the AC cycle with heat pump. So right now, this is strictly heat pump, air to air source heat pump, and what's happening is you have your low pressure vapor, which is going into your reversing valve, and that low pressure vapor is going to make its way over to your inside coil, where it's going to pick up heat from your compressor. Okay. Now, what's going to happen is that heat that's within your vapor compression cycle at your condenser is where you're going to have either your hot air being sent out or blown from a condenser fan motor into the space, or if you're going to be dealing with a domestic hot water system, that heat transfer is going to go into your water source. So if you're doing AC, you're going to have hot air being blown out over a heat exchanger. And if you have hot water that needs to be created, it's going to go through a heat exchanger, and that heat will enter the cold water coming in. Then you can transfer that out to your hot water that needs to be sent out to whatever spaces or zones where it's required or needed. Now, in a AC heat system or air conditioning system, this process simply reverses. So one process, as far as the vapor compression cycle, goes in one direction, but if you switch the mode, if you go into heating mode if you go into cooling mode from heating mode, that process is going to reverse, and therefore you would have a reversing valve somewhere in that system. Now, that is only when you have heating and air conditioning combined together. When you have heating and air conditioning combined together in one system, you will always have a reversing valve, which allows the mechanical system to reverse the vapor compression cycle. You cannot have heating with your vapor compression cycle operating in the same manner. It has to reverse. And what's really happening essentially is your evaporator and your condenser are reversing roles. So your evaporator is going to, in heat pump mode, absorb heat in order to provide it to the condenser to either heat your space or heat your water. In cooling mode, your evaporator is going to absorb heat to reject it to the condenser. So that way, you can have your space where the evaporator is located nice and cool. So whenever you think about heat pumps and how they work versus a heat pump embedded in an AC system, all I'd like for you to remember is that the vapor compression cycle reverses, and that's due to the reversing valve that is installed inside of a air conditioning heat pump system. Now, directly to the right, what you have is a water source diagram. It is the same exact process that's happening in your air source, but what is different is that the medium being utilized instead of air being the medium where your heat is being transferred from, you are going to use water as your medium or source for the removal of heat to be extracted and then transferred into whatever application you need it to go into. So this diagram here is the same thing going on here. You just have air source, which is this, and water source, which is here. And we'll jump into those different sources when you talk about the types of heat pumps available here shortly. So here we have our three different types of heat pumps and systems that you will find. And heat pumps, as we know, they are very versatile in both its design and or the source where we are looking to extract our heat in order to provide it to the application. Now, once again, there are a few different types of heat pumps available, but the most common are the three that you see on screen here, which are your air source, water source, and also your ground source heat pumps. Now, each of these, we just went over the air source heat pump, but what I want to do is I want to go through each one of these just so you have a better understanding of what's going on in each one of these systems. Now, on the previous slide, we spoke about air source heat pumps, and your air source heat pumps are the most common type of heat pump available today. If you are looking for a residential heat pump, more than likely, if you live on the East Coast or in the southern part of the country, you're probably going to go with an air source heat pump. Now, today's heat pumps that are air source can reduce your electricity use for heating by approximately 50% compared to your electric resistance heating, such as any furnaces that you may have in the home or any electric rated heating systems. Now, air source heat pump technology has advanced over the last few years that now they offer space heating in even colder regions. So I know someone asked the question to Christy a little bit earlier. She answered it about the refrigerants available today, which makes it easier to allow these heat pump systems to operate in colder climates, or allows them, period, to operate in colder climates. I know roughly 15 years ago, I installed a couple heat pumps at a site, um, and this was in San Antonio, Texas, pretty hot there, and this was around November, December, around this time of the year. And what happened was after we installed the heat pumps, we were called back to site because the end users of that heat pump system, those heat pump systems were not able to get satisfactory heat from the systems. And that's because that year in San Antonio, the temperature dropped below 32 degrees. Now, around that time, heat pumps were not able to operate without auxiliary or backup heat, anything under 32 degrees Fahrenheit. But in the last few years, we have been able to work on the refrigerants that will allow us to take the operation of those systems even further down as far as ambient temperatures are concerned. So now we can operate, as Christy said earlier, there are some systems that can operate as far as domestic hot water production down to negative 20 degrees Fahrenheit. And we'll get into some of those systems and what they look like here shortly. But in your air source systems, what is happening is you are basically using a heat pump system in order to remove the heat content out of the air to provide it to either your hot water source that you're needing or your heat for the home that you're going to require. So all it's doing is removing the uh, heat concentration from a certain temperature of air in the ambient air or air outside. Following your air source heat pumps, you've got your water source heat pump. And like I said, we basically understand, Christy mentioned it earlier, that what a heat pump does is it takes the heat energy from one source and it transfers it to another. So that's what's happening here. In our water source, what we're doing is we're removing the heat content from the water source, whether that's a well or a man-made type of built water reservoir reserve. We are removing the heat content from that water source and we are transferring it over to where it is needed for either the production of domestic hot water or heat. And your ground source and water source pretty much are going to be considered the same just because they are of the geothermal background. So geothermal heat pumps achieve higher efficiencies by transferring heat between your house, the ground, or some sort of nearby water source. Now, these geothermal systems, whether you're talking about water source or ground source, can reduce your energy use by 30 to 60%, controls the humidity, and is pretty sturdy and reliable if you're utilizing it in a region where it is able to be uh, uh, used. The reason I say that is because when using a geothermal source, you do run the risk of triggering earthquakes, but that is all up to the engineer that is going to work on your system to let you know whether or not your region is able to handle this type of source for heat pump systems. Now, following our different sources of heat pumps, we do have our heat pump applications. I'm going to go through just this first slide here, and I think what we'll do is we'll break for our first break halfway here through. But let's take a look at some of the examples of heat pump applications in different settings. And we have residential, multifamily, and commercial. And the left image that you can see here shows a residential ductless mini split heat pump system, which is installed on the outside of a home. So what's going on here is if this is just a heating system, you will have your outside system, which is what is going to remove the heat content from the air and transfer it to your inside system, which is either going to have a blower that is going to blow across a heat exchanger that will provide that hot airflow into the space. In the middle image here, you have a series of ductless mini heat splits, heat pumps installed on the outside of a multifamily building. Now, each unit or apartment dwelling has its own individual system, and a lot of the time they're very similar to what you would see on a residential system. It all depends on how your installation, as far as your contractor and how they are able to install the outside systems per certain city codes and regulations, especially regulations which allows the unit and system to operate as efficiently as possible. Some contractors will install these systems without the proper requirements, which will not allow the system to operate the way that it needs to. These heat pumps, I want you to remember what they're doing is they're drawing heat from the outside air in order to perform the function that it's designed to do. So if you install this system where it is unable to draw in an adequate amount of air, then you're hindering the performance of the system. So all state, federal, local regulations, to include the manufacturer's recommendations for installation, should be followed when installing these systems. And then lastly, to the very right, we have our commercial application, which shows the VRF systems, or variable refrigerant flow systems. And these bigger systems, they serve your commercial and industrial applications for comfort heating and cooling. And you even have the option of heat recovery, where you can utilize any heat that is rejected from the facility to provide preheating to domestic hot water or heating to another application within that facility or site. So it is roughly 1 o'clock, Christy. I think this may be a good, well, on my end, I do apologize. I am Eastern time. We
Yeah, I was
are
just gonna
one
let everyone
hour
know, like
into.
you're not in California, so you're on the, you're in You're on the opposite side of the country. Yeah, I think it's 10 o'clock. This is a great time for a break. I chimed in because I want to mention it's been brought to my attention that the link, the handout, is actually for a different course. So in the chat, I posted a link that will take you right to our deck. We build our decks in Google Slides, so it'll take you right into it so you can see it and follow along. And we'll get that handout fixed for folks who are hanging on here. But yeah, Lester, I think we can take a break here.
All right. What are you thinking? 5?
5 minutes? Yeah, I think that'd be perfect. So let's meet back around 10:06. Everyone take a bathroom break, a coffee break, stretch your legs, walk a little bit, and then at 10:06 we'll come back together.
Their super greens are good, but man, everything else I can't stand. So yeah, man, you know that sucks. I'm sorry. My friend Mike had.
It's not 10:06 yet. I'm just gonna chat with Lester. So if you're interested in seeing like behind the curtain, stick around. Otherwise, enjoy the rest of your break. Hey Lester, we're a little bit behind, so I'm taking a look at the deck, and I'm wondering, what do you think? Do we want to skip some stuff today and try to move it to Thursday, or do you just want to try to? What's your thinking?
What I really wouldn't, I love the activities like Skokomish Tribal Community Center.
Yeah.
But I think just to cover the material, what we may have to do is have our attendees go through that on their own, and maybe we could cover more of the actual content today.
Okay, I was thinking along the same things. So perfect. We'll introduce it. We'll provide it. Folks who are coming back now, in the chat, there's a link to the deck, which I see a number of people are viewing it. I appreciate you being there. We host our decks in Google Slides, so you can download a PDF copy, or you can print it out, or you can just view it and make a copy and move on with your lives. Okay, yeah, I think that's a great idea, Lester. So cool. I'm going to disappear and we can continue on.
Awesome sauce. All right. So when we get there, I will explain what we're going to do with the next activity session. But when we left off, we were talking to the heat pump applications when speaking directly to HVAC, and we touched on residential, multifamily, and commercial applications that you will find for HVAC systems when talking to heat pumps. Next, we'll talk about heat pump applications in domestic hot water. And Christy touched on a few of these earlier, but some of the different applications that you'll find your heat pump domestic hot water applications or units or systems in is residential, multifamily, and commercial once again. Now in your residential systems, where in the left image here, you can see it shows an integrated or also called unitary systems whenever you have all the components of the vapor compression cycle installed in one system. It's also called unitary. But on the left image here for residential, you have a heat pump system, which is installed in a residential closet. Now, if you were looking to upgrade your current water heating system, you could do a like-for-like replacement with a heat pump system. You can have a heat pump system installed in your water closet, just like you would have a standard unit installed, and have the benefits of having a heat pump system. Now, if you have if you want to install the heat pump in a location where the airflow is not enough, you can also add these flex vents that connects to the outside that allows you to draw in the required air source and also evacuate any of the air source that you need to as well. Over in the middle image, we show several smaller heat pump systems, which are term utilized in the industry is ganged, G-A-N-G-E-D. These systems are ganged together in order to provide domestic hot water for a multi-family building. So depending on the size of the building, the amount of units available, the load, the capacity, you're able to either remove or add, or in the industry, what's termed as ganged. You can gang additional units in order to supply capacity for your multifamily setting. And lastly, to the very right, we have our commercial systems. And This commercial system is a commercial kitchen from Vermont. If you look up here in the top upper right corner, you'll see a heat pump that's used to provide domestic hot water for the restaurant. Now, another reason that you might need that domestic hot water is for cleaning your kitchen equipment and all other sorts of commercial applications. But you can today utilize heat pump technology for large commercial kitchens or even industrial processes. I just want to touch on the heat pump systems that you see in the commercial kitchen and the multifamily is the Sandin Senko 2 heat pump. Just some specs on that system for those who are interested. The hot water production is down to negative 20 degrees Fahrenheit ambient temperature. So you can have hot water production down to negative 20 degrees Fahrenheit utilizing the Senko 2 heat pump systems, up to 175 degrees of hot water temperature delivered. You probably don't want it that hot, but you do know you have the capabilities to provide that with a heat pump system. And the refrigerant being used is CO2, which is a newer type of refrigerant being used in these heat pump systems. And this specific refrigerant is very ozone friendly. So what's next? What's up and coming in the world of heat pump systems? On our image to the left here, what you see is a hybrid VRF system. And your VRF systems initially introduced were commonly found amongst commercial applications. And these VRF hybrid systems are starting to gain a lot of traction in the industry today. And the reason why is because they're really adaptable and easy to install and offer a lot of flexibility and function for specific applications. You can have heating and cooling provided from your hybrid VRF systems. Now, in the domestic hot water area or arena, we have the commercial heat pump water heaters, which are now being packaged together. So these systems no longer need to be custom engineered, they're just plug and play. Someone mentioned earlier about multi-stack systems. The thing I loved about multi-stack is the modularity of the systems. Multi-stack systems can be designed for an initial application, and if you extend on that application, and when I mean extend, I mean possibly having a higher heat load content due to more equipment being added to that zone, space, or application, you can just contact the company Multistack, and they'll send out an engineer to get a heat load calculation and decide what, or not what, but how much more capacity you would require for cooling or heating or whatever the application requires. And they would just create a separate, smaller system, and you would gang that on or attach that on or add it on to the existing system. Now, in the field, another term you may hear for this is typically slave and master configuration, where the master is the system that holds all of the programming capabilities, and all the slave system is doing is accepting the commands from the master controller in order to provide some sort of a output. So there's different terms that you might hear in the field, but they are very similar in kind. So once again, what's up and coming for the future? You have your hybrid systems and also your plug and play domestic hot water heat pump systems. I believe, yeah, there we go. So
this is where we would have released everybody to go and explore this, but instead, what you have is a QR code in front of you, and this is a great time to grab your device and capture that, or even if you want to just like capture the screen, it's usually alt print screen or control print screen. You can take a screenshot, and I'll throw a link into the chat as well, or maybe Jordan, you can grab a link and throw it into the chat too, since you're out there. But this is it's a link to a gateway to a virtual interactive tour of the Skokomish Tribal Community Center that uses heat pumps for both their comfort heating and cooling and their domestic hot water production. It's a VRF system. Uses the Mitsubishi City multi-units. It's really cool. You can walk through the entire site. You can see the technology. There's videos in there, so you can listen to the engineer talk about the decisions that he made to get to the place where they designed the system. This is normally something we would release to you to work on and then come back together and debrief about, but just for the sake of time, we're going to continue moving forward. But grab your device and capture that QR code or use the link in the chat and check it out on your own. It's a really cool site to visit, and it's cool to see the heat pumps in action.
Oh yeah, absolutely. And if you are into virtual reality 360-degree type of applications, this is a really cool setting because you could immerse yourself into the mechanical rooms and the actual site where the systems and units are installed. So I would encourage it, and just so you could have a better understanding of how these systems are designed.
And Jordan threw that link into the chat, so grab it, take it, explore it. It's yours to have and use as you'd like.
Absolutely. Thank you for that, Christy. All right, I'm going to pause here really quickly. I did go over a lot in a very short period of time. So, Jordan, if we have any questions in the chat, I will stand by to take those.
Yes, one question here. Are there restrictions on ground source heat pumps in California?
I am not sure of, and I can definitely get some information on that for you. I know a lot of, I want to say, anywhere where you are prone to earthquakes, you're probably not going to have the capabilities to do that. You may be able to get a surveyor to come out and do some really, really deep groundwork, but you know, it's not even worth the risk. Because once that starts, you can actually create more problems with the way that you can cause more problems with earthquakes and seismic activity if you're not careful with those types of systems. So that's why there are probably really strict regulations on where those systems can be installed or even placed or put in operation. But I'll definitely look and see what regions in California geothermal sources are capable or able of being installed in. There may be some, I'm just not too sure of.
You know, in this same vein here, why do ground source heat pumps create greater earthquake risks?
It's predominantly due to the digging and the vibrations of the system whilst it's deep under the ground, deep under the earth. You know, it's like if we have any divers in here, if you dive, a lot of the time when you're learning to dive, your instructor will tell you not to interfere with anything on the ocean floor, like coral reef or anything like that, because it could damage it. And that, you know, that works on the ecosystem of the sea life if you damage a piece of coral. So I think it's along those same lines as far as disturbing something. But we have the insight to know where and when we can install those. So we have to be proactive as far as, you know, getting the proper engineers out there to survey that land and make sure that the region, that specific region, is able of handling this type of system.
And Lester, one last question. Someone is interested in the costs of these systems.
Very expensive. When you start talking about digging and piping for geothermal systems, you're going to spend a pretty buck. But the thing is these systems have been proven to save even more money than your standard heat pump system, such as your air-to-air source heat pumps. But like I said, installation is going to be extremely costly, and maintenance could even become an expense as well when dealing with these systems. So you have to make sure that the application that you're needing it for will be able to use it, especially your region. You have to very, very strongly consider your region when talking to geothermal sources.
Yeah, I think they wanted to make sure that it's worth the investment to get heat pumps.
Oh yeah, absolutely. You have to make sure it's worth the investment because, like I said, installation is going to cost you way more than your standard air-to-air source, and also maintenance is definitely going to cost you because you will need someone who understands the operation and maintenance of a geothermal system.
And that looks like everything here right now.
Okay, awesome sauce. I do thank you all for the questions. I know it's a little pressed today, but Christy and I will hang on for a little bit after this so that way we can get to some of the questions that we may not have had the opportunity to. So as we press on, now we will get into the different types of configurations for heating and cooling equipment. So for comfort heating and cooling, your heat pumps can be used in a lot of different ways. So we'll take a look at a couple of the common heat pump or heating cooling configurations for heat pumps in residential and commercial applications. So here on screen, you can see we have three that we're going to take a look at, which is your mini splits, your VRF or variable refrigerant flow, and monoblock systems. So your mini splits, this is a very common system. A lot of us are very used to having these systems in our homes, and these systems have different zones that require or need control. So you would be able to utilize these systems where you have different specific zones in a home that needed a type of temperature control. Okay, the mini splits come in a few different flavors or types, and the two types of flavors that the mini split systems can be found in is the single and the multi setup. Now, your single type of setup system is a single zone mini split system, which is designed to heat or cool just one single room. So if you take a look at this mini split here, you have the outside unit and you have the inside unit, and you notice it's only in one room, right? So it's just that unit to this room, and that's it. Let's ignore this one down here for a second. But your typical single zone mini split system is going to only satisfy one room. Now, if you have a multi-zone mini split system, multi-zones are designed to heat and cool multiple rooms or zones in a home. These systems consist of one unit and up to 8 indoor units. So in this specific setup that we see here, where we have our ductless mounted air handler, and we have one unit outside, we're able to utilize a mini split in order to cool off more systems within, or more spaces within the home. Okay, so once again, your mini splits, different flavors. You have your single and your your multi-zone systems. It depends on your budget, and also uh, how many rooms are you looking to heat and cool? Because you may not want to heat and cool every room in your home. It may just be specific spaces. The types of the types of inside units that you're going to find when dealing with your mini split system are your ceiling cassette type, wall mounted, concealed duct, and also your floor standing. So up here you can see we have a cassette type of mount. And this type of mount is you'll find on a lot of mini split systems, but it consists of something similar to your diffuser type of setting. Your wall-mounted systems, as you can see here, ductless wall-mounted air handler systems. These can be mounted directly on the wall of your zone or your space, and will provide the heating and cooling for that area. Whereas your cassette-mounted will be mounted in a ceiling or some sort of a drop ceiling grid, so that way it could provide the flow of air coming down into the space. And then floor standing systems will just be mounted somewhere resting against a wall, which is another great option if you don't have enough wall space for a wall mounted type of setup, or you're really short on space period, where you can't even get a cassette type of installation in there. So you may have a floor standing system, which will work perfectly for that type of setup. Now, your variable refrigerant flow or VRF systems, and let me make sure I explain that your VRF stands for variable refrigerant flow, which is exactly how these systems work. VRF systems have been in use for quite some time, over 25 years. I know I worked on this type of system about roughly 15 years ago. I was introduced to the first one that I was able to put eyes on, which came over from Germany. And it was a very interesting system because these systems were able to provide heating and cooling utilizing one outdoor uh, condensing unit. And it's a system that has one outdoor condensing unit, which is piped and connected to multiple indoor units. Um, the VRF systems do not require a lot of refrigerant, but what happens is, as far as using these systems, it doesn't require a lot of refrigerant to be piped through an entire site or zone or facility. But the really cool benefit about these systems is that they can save a lot of space where you would otherwise have to dedicate that space to ductwork for any type of traditional hydronic system. But because these systems utilize refrigerant, this can pose challenges with uh, code violations for specific sites, especially where you have occupied space by human occupancy in certain spaces. This can hinder your installation of a VRF system just because you have piping that will be traveling overhead of an occupied space. So you have to pay very close attention to local guidance. As far as I know, California's Title 24. Not only do you want to focus on that, but you want to focus on any local guidance, county guidance that can be of service when performing installation of these different types of systems, just so you don't get fined or get yourself in any type of code violation.
Yeah, Lester,
But
there is a relevant question here. There's safety concern about refrigerant leakage and loss of life. Is this an overblown concern on VRF
it's not.
systems?
Yes, that's a great question. It's not an overblown concern, but what has happened is the code writers have been informed that this could be a potential issue. So what happens now is for specific applications, before you even get started or granted permits to work, you're going to be questioned heavily about what is ultimately the purpose for that space. Is it going to be occupied by human personnel, and if so, how many hours out of the day? If it's just a temporary, maybe in and out type of situation, you may have the ability to go ahead and install that system. But once the use of that space changes and it goes against the guidance, then at that point you're going to have to either make the changes so that way you are within the guidance, because you don't want to be fined for these different issues or have any liability issues where you may happen to have a leak and it does cause some sort of loss of life or injury to life. So yes, you want to make and pay close attention to the different codes that are available to you, whether mechanical or electrical in nature, when it comes to these types of systems. All right. Yes, so your VRF systems, once again, stands for variable refrigerant flow, very flexible systems, up and coming, a favorite amongst contractors for large commercial sites, a lot of modularity, a lot of functionality in these systems. So as long as you have the cost and you are within the proper regulations to use this application, it's always recommended. Now, this slide here just kind of shows you what a VRF system looks like when installed, so that way you can see it in operation. But before we go into that, let's look at the very left here. On the top left, we've got the rooftop compressors. So the VRF systems are all lined up and installed on your rooftop. You can have them installed there or on the side of the building, but wherever your most available space is, where you can have these systems operating efficiently with the proper amount of airflow around that system is where you're going to want it. But here in this configuration, all the VRF systems are installed in line on top of a rooftop. You can see the inside unit for those VRF systems. You can have different types. Here you can see the wall-mounted type that we spoke of earlier. And what is happening here is you have the operation of whether you want heating or cooling coming from these systems, but they're wall-mounted, so they'll be able to send that airflow out driven from a wall-mounted system. Or if you don't have this type of space or setup within your zone, you can have the ceiling cassette type, which is usually found on your drop ceiling type setup, whether that be a classroom or an office space. But if you're like maybe working this out of a warehouse or some sort of a more industrial type of setting, you're probably going to see your wall mount setup within that zone. So it depends on your application, what type of interior unit you're going to have, but for the most part, your outdoor system is going to remain the same. And just want to make sure with your outdoor system, this system is needing to receive adequate airflow. Your contractor will know exactly what to do with that, just to make sure these systems are operating efficiently. So to the right here, we can see we have our one outdoor unit and 1, 2, 3, 4, 5, 6, 7, 8. So up to 8 systems we've got here. I believe the VR systems can work many more, but it depends on the capacity of that specific system by that specific manufacturer. But what you can see here is you have a branch unit that is able to branch off the refrigerant and the flows of that refrigerant to the systems that it requires in each zone. So what's happening, you can tell by the color of the space, what mode or setting of airflow is being requested or required for that zone. So in this here, where we've got the red, looks like they're wanting heating. So your system, your one system here is able to provide that heating and also provide the cooling for these zones as well. And that's where you have the variable refrigerant flow option when dealing with these VRF systems. And that's another reason why our contractors like to recommend this, because you are reducing the number of units that sit outside of your facility, but you're also able to increase the amount of spaces that you can provide heating and cooling applications to. Next, we have our monoblock systems, which is a comfort heating and cooling system where all the components, just like a unitary system, are packaged together inside of one single box. You can see the system installed here on a wall. You may also hear these systems called packaged terminal heat pumps. The monoblocks are great options for multifamily buildings or buildings that have several separate zones with individual heating and cooling needs. And typically you'll find these monoblock systems installed on the wall, the ceiling, or the floor, and requires ventilation to the outside of the building. So where this system is sitting right now, it is venting directly outside of this door, and that is how this system is able to stay in operation.
Lester, we've got an interesting comment here. Usually the minimum outside air, fresh air, is an issue with the mini split wall or cassette type fan coil units.
Outside air, did they say the outside air is an issue?
The minimum outside fresh air is an issue with the mini split wall or cassette type fan coil units.
Yeah, it could be. It could be. And the reason I'll agree with that is if you don't have adequate airflow inside of your space where you have a mini split system installed, yes, that definitely could be an issue.
They say for ventilation purposes.
See, the thing is with mini splits, you have to have an alternate source of airflow. It's not like your typical hydronic system where you have fresh air intake coming from an air handler system that is required by law to be open 10% at the very minimum. On your mini split system, because those systems are working DX, meaning direct expansion, so it's utilizing refrigerant as the direct medium for heat exchange, that system is going to require a different means of fresh air being introduced into that system. So whether that's your front door opening and closing or a window being popped open here and there, that is typically the only way you're going to get a good fresh air changeover within a split system. But when you have a more a bigger system, or more on a commercial level, your air handling system is typically regulated to be open at 10% minimum to provide that fresh air introduction into that space. So hopefully that answers that question with these mini split systems. It's based upon how your site is designed, and you're going to have to figure out how that airflow is introduced into the space, whether it's by louver installed in a door, a window, even an exhaust fan installed in that space as well. There many different options that you can choose from.
Yeah, Lester, they're agreeing and referencing that an alternate source is needed.
Absolutely, and like some sort of an alternate. My recommendation for mini split systems is you can do it. You could do a natural draft or natural type of ventilation or introduction of fresh air. My recommendation is if you don't have that type of airflow in that environment, by opening a window or a door, make it mechanical. Install a what do you call that? Like an exhaust fan in that space. And there are exhaust fans today that are, you can literally hide them and they're very quiet. So that way, if design factor as far as the ambiance of that space is important to you, you can just find those little design factors and cover it up. But definitely you can have it done. Um, uh, but with like I said, with the hydronic system, you don't even have to worry about it. By law, it has to be done. So you'll always have the introduction of 10% fresh air. Hopefully that answers that question. We do have just a few more things on the monoblocks I just want to cover. You have a few different configurations of how you could set those up. I know we covered this one here on the wall, but the window setup is one of the most common that you'll find as far as your monoblock or unitary systems. So window units are another type of monoblock system. Then you have your portable mobile systems, your wall mounted, and also your floor mounted. So we just covered the types of configurations for heating and cooling when talking about mini split systems, variable refrigerant flow, or VRF, and also our monoblocks, which are the unitary systems in the heat pump heating and cooling configuration world. So we'll pause here just in case we have any further questions that may be in the chat.
Yeah, Lester, there's just a couple of follow-up comments on that topic of ventilation. Maybe a barometric damper, and someone asked to like a toilet's exhaust fan with the filtered wall louver for air, for making up the air.
Yeah, like I said, any type of mechanical driven systems, in order to increase that changeover, would work. You can install an exhaust fan. You can even there are other things that you could do with the what do you call it, with the system in itself. There was an issue with humidity, but that's a whole nother topic when talking about relative humidity. But you definitely can introduce a form of mechanically driven air changeovers, and exhaust fans are my preferred choice of doing so. I would install an exhaust fan so that way we can introduce and exhaust air into that space, whether you're doing a supply and exhaust or just one. But you just need some sort of changeover, and if you're not getting enough of it by just your windows and doors, then you definitely need to think about a mechanically driven option.
And Lester, there's a few more questions too about the ground source heat exchange. I think it's related to the earthquakes. Sorry, give me just a second here.
Take your time.
So what about shallow ground source heat pumps? I don't think they dig too deeply. And there are also above ground water source recirculating heat pumps that can be used without having to go underground and use water wells.
I'll talk to the water source really quickly. Yes, that's correct. There are water sources above ground that can be used, so you don't have to worry about going underground for water. Those systems are a lot more complicated. There is a lot more maintenance involved. when dealing with these above ground sources. But I think there was something mentioned about a shallow installation. I'm not familiar with that. I know when these systems are installed, they're installed, as far as the piping is concerned, it runs pretty deep. And I think the deeper they go, the more heat they're able to absorb from that ground source. So uh, yeah, it definitely depends. Once again, region plays a big role in whether or not that ground source is um, readily available to specific customers. Uh,
There's a link provided in a comment here. The attendee wants to share that the district energy ground source heat pump system in Richmond, British Columbia, Canada, located as part of Cascadia subduction zone, and it's at risk of liquefaction. Is this project doomed when an earthquake happens? I can share the link to that into the chat for following up on details.
yeah,
And
absolutely.
um, there's also a comment here for multifamily housing in many sites, we're required to provide MERV 13 filtered air supply to each unit.
Okay. So, MERV rating 13 for that specific filter. Filters, as far as the MERV rating is concerned, that is application specific. Commercial and residential have different requirements. So, once again, it depends on your application ultimately. And specifically when it comes to filters and MERV ratings, that's very important for the individual that put that comment in there. MERV ratings are very important because that's how you control your environment as far as filtration is concerned. We won't jump into that. That's a whole nother topic when talking about air handlers and filtration. But any other questions on the heat pump topic?
That looks to be everything at this point.
Awesome sauce, awesome sauce. Do appreciate the questions once again. We're driving a little quickly here. We're hitting the gas, but we're still on track. So please keep those questions coming. Just want to make sure we cover a lot of the content that I do feel is important for this first part of our course today. So let's jump into some HVAC heat pump essential considerations when talking about design, any type of planning when dealing with your spaces, and also refrigerant. Because all three of these things are very important when you're looking to install these different systems. And you want to make sure that you take into account several different important considerations. And like it says here on screen, some of those considerations are going to be your design footprint, your space planning, and also your refrigerant. Now, I do want you to keep in mind when referring to refrigerant, there's an important part that we're going to talk about, which has to do with safety and code requirements. And this deals directly with ASHRAE codes 15 and 34. We're going to talk a little bit closely to that here as well. So not code considerations, but considerations on installation when talking directly to design footprint. Your heat pump system or your heat pump comfort heating and cooling system can come in a lot of different forms, as we can see here on screen. And the systems in itself are pretty much generally hidden, but they can take on a few different looks. So some of those looks that we can see here more in detail, in depth, is our ceiling cassette. Some of us are very familiar with seeing this type of setup here at like maybe an office setting. You have your ceiling cassette. You have filters that are situated in these little slots here, maybe one or two of them, where you could pull that removable filter out, clean it out, and then put it back in for your air filtration. And then you have your diffusers, which are off to the side. Actually, your filter will fit right in this square here, if I remember correctly. Yep, you pop that deck down, filter drops, you can clean it right out. But your diffusers for this system, where your airflow actually flows out of, is going to come out of this diffuser here. Sorry, very, very touchy on the mouse today, sensitive. So yes, right here will be where your airflow comes out from. And then you have your wall mounted or wall cassette type. similar to what we spoke about earlier. You'll find these a lot of the time in maybe a residential type of setting. And you know, I feel like they're pretty decently installed or situated units in a residential setting, as long as you have it installed somewhere where you know it's off and fits that design footprint. And then to situate your heat pump, your outdoor systems, how they're situated. I always like to say when I do this presentation here that this is one of the prettiest setups I've ever seen in my life. I actually like it a lot. I love this setup here. It's gorgeous. I mean, you have all your heat pump systems outside of this facility, and it looks like they've calculated for the much needed area of space around each system, so that way each system can breathe and do the work that it needs to do properly with the correct amount of space around each one. So you want to make sure that you keep your design footprint relatively clean. It also makes for maintenance a lot easier. And lastly, to the right here, we've got our monoblock. I've typically seen and worked on these a lot of motels, hotels, are where you'll typically see your monoblock type of setup. And once again, these monoblocks have everything installed inside as a unitary system, and you need some way, wherever they're installed, hopefully the backside of that is a wall to the outside where you can evacuate your heat exchange. Now, talking about considerations as far as installation, your spaces, your floor space in this type size of building is pretty premium. You want to make sure you are accounting for all of this space and using it as much as you can as far as efficiently. So what is going on in a site like this or a facility like this is um, you're typically going to have some sort of hydronic system, as we can see here, installed in a facility like this, commercial size facility, where you have hydronic. When dealing with hydronic systems, you're dealing with air handling units in mechanical rooms on each floor, as you can see in these green rooms here. But when thinking about potentially performing an upgrade and you're thinking, hey, I can make this more office space where we can put more people to answer phones or do more work or whatever the case may be. You can decide, well, I'll go with an upgrade where we can get rid of these air handlers. And the way that you would do that, well, one example would be to install a VRF system where all of your VRF systems would be situated on the rooftop, as we seen earlier, and then you just have your inside unit installed, whether in the ceiling grid or on the wall somewhere, which would completely eliminate the need for these huge air handling units and this huge cooling tower and all of this chill water equipment and hot water equipment located in the basement. So what that does now is it opens up all this space and you can utilize it now um, for whatever reason that you may need to. So considerations in the beginning when you are performing these installs, you want to think about your real estate and how much it means to you, and whether you want to spend the money up front to create something now than making upgrades in the future. Your refrigerants are another important consideration, especially when you're talking about VRF systems that typically pipe great amounts of refrigerants throughout a system, especially in larger tonnage systems. You have what's called GWPs, or global warming potentials, involved when talking about different refrigerants. We can see here our arrow shows us what are some of the worst refrigerants, and the ones that are getting better are the ones currently in circulation amongst these different systems. A lot of these refrigerants down here, I'm very used to them. I used to work with a lot of these, and it's just it's almost surreal seeing that these refrigerants, a lot of them now on the EPA's ban list, like as far as being manufactured, cannot be anymore. And I used to really work with these and use them in different systems. But here, this list here shows some more commonly used refrigerants that are deemed better for the environment. And I will say that ammonia, CO2, and propane are now some of the more popular refrigerants because they do have a lower GWP. Um, and they are some of them being used today in the United States. Ammonia and CO2 for sure. I know propane I've dealt with overseas. I have not seen propane stateside, and I don't believe we are regulated just yet to utilize propane. But it does have an extremely low GWP, and it is very popular type of refrigerant to utilize overseas as well. So just some considerations when dealing with your design footprint, spaces planning, and also refrigerant. You want to make sure you have the space to perform the installation that you're trying to have done for that specific application. And you also want to make sure your design footprint is clean. It's very well kept behind. So that way the client is happy with the way that the installation is and looks. And also you want to be concerned with your refrigerant if you're using any type of refrigerant that is going to be piped through a occupied space by human personnel. You want to make sure that you're following proper regulations when dealing with ASHRAE 15 and 34, which we'll talk about as well here shortly. Now we do have another catch and release here. I know Christy went over this earlier with the other one, but this is just another catch and release. You will have the slide deck to jump into this and take a look at this case study. And then answer some of these questions, or even just to read through the case study. It's going to be a good reading for you to understand more about these systems if you do have time for that type of a deep dive. All right, I'm going to pause here shortly just to see if we've got check in, see if we've got any questions, and then we will move on to heat pump essential code considerations to end the day.
Yeah, Lester, one question here. Are mini split systems efficient at removing humidity?
They are. It depends on the tonnage. It depends on if that system can keep up with the space that it is installed in. So heat load calculations are really, really good for really good to be done. Because what that does is it actually helps you predict what type, a little bit over sometimes, what type of heat load content you'll have in a space, even on its hottest day, to include your humidity or relative humidity percentages. So it's going to depend entirely on the size of the unit and the current ambient temperatures, and if you've factored in the heat load calculation for that specific space to handle high humidity and high temperature.
So there are a few other questions that are slide specific, but maybe we could loop to those at the end.
Absolutely, I do appreciate that. We will come back to those. The slides on our essential code considerations are not too long, so let me go through those and let's see how much time we've got left in the end to go through some of these final questions. So we've got heat pump, HVAC heat pump essential code considerations. I touched on Title 24 a little bit earlier, and Title 24 is specific to California. It's 12 parts to the Title 24 code that pertains specifically to heat pumps, comfort heating, cooling systems, and I think it's worth anyone's time investigating, especially if you're dealing with this type of these different types of systems. Now, there are a few parts that I am going to recommend that you focus on as far as Title 24 is concerned. When dealing with heat pump systems, you want to be concerned with Part 2, which is California Building Code, Part 3, California Electric Code, anything that has to do with NEC, Part 4, Mechanical Code, and the Mechanical Code specific to California and its appendix, Part 5, Plumbing Code, and Part 6, California Energy Code, which is going to deal more with your demand response requirements. So parts 2, 3, 4, 5, and 6, you want to stay focused on when working with Title 24. These will really gear you to what you need to stay focused on as far as installation, maintenance of these heat pump systems, whether you're dealing with the air conditioning side and heating or the domestic hot water side. And I did mention ASHRAE 15 and 34 earlier. When talking about ASHRAE 15, this specific standard is just directed towards the safety of persons and property near premises where any type of refrigeration facilities is located. So when dealing with any type of refrigerated facility or facilities that have refrigeration systems running through them, you're going to focus on ASHRAE 15. But ASHRAE 15 and 34, when you see one, you're going to see the other. So you're always going to want them nearby each other, because ASHRAE standard 34 is a system used for assigning reference numbers, safety classifications, and refrigerant concentration limits to these different refrigerants. So this should be used hand in hand with ASHRAE 15, and it just establishes a simple means of referring to common refrigerants instead of using the chemical name or compound formula. So once again, ASHRAE 15 and 34, you want to be familiar with these regulations. You don't have to remember them, but you can definitely get a copy of each one and use these to understand the different requirements when dealing with refrigerants in specific. So we do have a section here. Christy, do you want to go over that?
I think we should skip ahead
Yeah.
because we've got questions in the queue, but also I want to give folks a chance. So if you could skip to the next one, Lester. We have a survey we'd love you to land on. This is a survey to check your understanding, to see that we hit the benchmarks that we are aiming for. It's a place where you can provide us questions, comments, feedback. And again, we take it really seriously. We look at what you say and we use that moving forward to make our webinars better. So grab your device or open up a new web browser tab and go to slido.com, enter in the hashtag heatpump. This just takes a couple of minutes. I want to say it's like 3 or 4 or 5 questions, a couple about content, and then one, like, tell us how we did. What would you like to see next time? I see 3 people, a couple of people already participating. Thank you so much for that. We really appreciate it. We'll hold here for a couple more minutes, and then just looking into the future, the last slide will have a link to the survey for PG&E, which is one that you can fill out when you get a free moment. PG&E then takes that information and uses it to continue to offer courses and webinars to you. And then that will be it for today. We'll be wrapping up. So grab your device, hop into this check for understanding, let us know how we did, let us know whether or not we met our benchmarks. And while we're doing that, I think we have time for maybe one more question. So Jordan, is there a question floating out there in the Q&A?
So there's a specific one or two here, maybe about heat of the systems and the distance that you can run refrigerant. I think this was related to the slide about space planning in the larger multi-unit building. I think slide 44, if the refrigerant would the compressor be able to pump refrigerant that far?
Yeah, so there are going to be limits to how far your line set runs. And that is all design factor, depending on the zone, like not the zone, but the space that you're installing that system in. If it's a multifamily building and the reach is easier for it to be, when I say reach, I mean as far as the setup, so your compressor or your outside unit, if it's easier for it to be installed on the rooftop or maybe right outside the window of that unit, it will be determined at that point, because like I said, your line set is going to, there's a requirement there. You can't run your line set beyond the design factor, because if you do, then you're just not going to have your system operate efficiently.
Sounds good. And I guess one more comment here about maybe the slide just before that, heat coming off of the outdoor heat pumps. There was a photo of a lot of units on a wall getting together, and if that was hot.
Yeah, so you have so many different configurations. I know Christy could talk to a few of these, like the way that some of the heat pumps are situated in garage spaces for multifamily setups. But that type of setup that you've seen on the exterior of the building, what you'll actually notice is the air coming out of that system is going to be cold. It's not going to be hot. Now, if that system was an air conditioning system slash heat pump and you were in cooling mode, you definitely would have a lot of heat coming off of those systems. But that is not something that you would find uncommon anywhere. It's just heat being rejected to the ambient space. So it's quite fine, it's quite okay. But in the reverse, just know if you were to put your hand over those systems in heating mode, that airflow coming out would be cold.
And that doesn't really happen with domestic hot water heat pumps, right? Like we're never gonna take hot water and cool it down. So that is mostly for comfort heating and cooling applications.
Mm-hmm.
I think
Absolutely.
it looks like not a lot of people are continuing to work on this survey. So let's go ahead and move forward, and we'll land on the link. Jordan, if you could grab, keep going one moment. Jordan, if you could grab that link and throw it into the chat. So this is the survey for PG&E. They'll be sending out a copy to you, I believe. Take a couple minutes, fill it out. PG&E uses this data to continue to offer free classes and webinars. So if you have 5 minutes in the day and you can help them out, they'd be super appreciative. And so would we. We take those results also really seriously. They share them with us, which is great. Brian has been really proactive about that. And I think it helps make our decks and our presentations even better every time. So we are at 11:02. We're 2 minutes over. I'm so sorry about that. We want to be respectful of your time. If you need to go, please do. And we look forward to seeing you back here on Thursday. Same time, same place.
Absolutely.
We're going to stick around for another 2 or 3 minutes, but please feel free to log off. Awesome. Thank you, folks. Thank you for logging in and joining us today. We're just going to hang around.
Christy, you there?
Yep, I'm here.
Hey, just real quick, I uploaded the correct file to the handouts tab so they can download it. I also know you put it in the chat as a link.
Awesome.
Download that. I'll hold on for another 5 minutes and allow people to download this if they need to. Just a reminder, please join us same bet time, same bet channel for part 2 of this class. And then also the Survey Monkey. Please, please, please help us with valuable feedback for this class. This also enables you to give us any new class offerings that you'd like to see at PGE. So please utilize the Survey Monkey. And thank you very much for your attendance. And I'll hold for 5 minutes.
I was actually just looking at, Brian, the survey, some of the results you sent us over from another course that we offered. And looking at it, I was like, oh, these are great ideas. Like, we should do this. So I love, there's some comments about, like, we love the case studies. We love to hear you speaking about projects you've worked on. And that to me is really good to hear because, like, putting those things together, webinars is a lot of work. So it reinforces, like, we need to continue to do that. We need to speak about experience in the field. So, yeah.
Absolutely. Thank you so much.
So we have a comment in the chat. Would love to know more about cold climate heat pumps. I hope you join us again, Kelly, on Thursday. We'll be talking more about heat pumps for domestic hot water applications, but we'll also be looking at those heat pumps and refrigerants that make them applicable for cold climate applications. So I think this is going to check your box if you show up again on Thursday. And remember that Brian records these and posts them for on demand. So if you can't make it on Thursday, make sure to check his website. Remember the QR code at the start of this webinar. Go and check it and find it. You can find the webinar. You can watch it then on your own time if you're not able to make it. Okay, Lester. So I think it's about time that we log off. Thank you, everybody, for joining us. Again, awesome conversation. Really appreciate your attendance. Brian, you're going to hang on a little bit longer?
Yeah, I'll hang on for 2 or 3 more minutes, allow people to download the slide deck in PDF formats. So I'll just hold on for another 2 or 3 minutes. Hey, Kelly, just a reminder about heat pumps for cold climates. I have a couple of classes on our website now specific to mini splits. You can look that up, and it does discuss some cold climate applications for those systems. I was in a class, a heat pumps class, like 15 years ago with another utility, and it was when heat pump technology was just coming into play. I mean, this was like 17 years ago, and I was sitting next to 2 guys from Alaska, and I was like, what are you guys doing here
Right.
a heat pumps class in California. They said, well, this utility is the only one that's putting this on it at this time frame. But they started to tell me that that's what they utilize primarily in Alaska for like outlying areas. They will hook up a heat pump and then utilize it on a generator for power. And then they'll keep, a warehouse or something of that nature just above freezing. And so I was kind of interested in this, and I was talking to them, and they said, yeah, what will happen is we'll put this heat pump in, and then it will, because of its defrost and this defrost period that it has to go through, it will go through that process like every 15 or 20 minutes. And it would build a snow cave. So it would defrost, melt the snow around it, and then it would basically, the heat pump, the outdoor unit would be encompassed in a snow cave. I just found this fascinating that, we could utilize that technology in such an extreme climate as Alaska. So I live in Tahoe. A lot of heat pumps are being installed up here now in the form of mini splits. And they actually have several cold climate applications. And so different manufacturers have systems available that will go down to -30. So if you're interested in that, I have a class. It's put on by Dan Franco. It's the mini splits class. You can find that on our website. Thank you so much for joining us. And if there's not any other questions, I will sign off. So I hope everyone got an opportunity to download the slide deck, and we will see you Thursday at 9 a.m.
Because a PM to bring it up shouldn't take more than the entire year contract.